Hello, my name is Richard Arnett, and I have started the project or posted the project on experiment.com under the title name of ChromatograDIY. That's DIY. The goal is to develop a gas chromatograph from scratch. Um, the ultimate goal is to develop high quality, inexpensive laboratory equipment, but I have tackled as my first project a gas chromatograph. My interest in this area began with interest in microcontrollers, open source microcontrollers such as the Arduino Uno card, which I was reading up on and had gained interest in, and had read books such as Makers from Chris Anderson, and I had started reading books such as Raspberry Pi and Arduino books, programming, and subscribing to Make Magazine, which I found very interesting. I believe heavily in, at first my interest was mainly in what microcontrollers could do, and this went from everything from building your own drone to programming your refrigerator to having your microwave tweet you when you had your food ready. After more serious thinking, I decided to tackle something I know very well, which is laboratory analytical equipment. I have been working in the research and analytical field for 3 major petrochemical companies for almost 18 years. I worked for Shell Development Oil and Chevron Chemical and Dow Chemical, and a couple of small research facilities in between. I came to realize that a lot of the equipment that I used every day in the lab was very expensive, high quality, but could also be very easily controlled with these microcontrollers. The Arduino and shields such as the reflow shield. This is a shield that goes on top of the Arduino and gives me an LCD display. It is hooked up currently to a thermocouple and has 2 outputs for relays. One goes to a relay in my heating, and right now I just took a basic space heater. This is a 1500 watt space heater with a heating coil and a fan. And if you're familiar with gas chromatographs at all, this is the most important part of the oven, which keeps the column at a constant temperature. You need a heating coil and a fan, and so I have 2 separate relays. This little relay right here it's a little solid state relay that controls the fan, and the larger one that controls 1500 watt heating coil. The reflow shield I like because it has the LCD screen and the 2 solid state relay outputs, but there are other shields that hook directly to the Arduino, such as this smaller one, which is mainly just a thermocouple input. But the Arduino is very capable of interfacing with just about anything analog and digital, and it can take information in and it can send signals out, so it's very good at controlling equipment and data acquisition. I decided to leave my desktop messy for a reason, and that's just basically just to show that work continues constantly. I have been working on this for probably about 6 weeks now. I started probably right about New Year's and really getting into it about the 2nd week of January of 2014. I've been learning about the Arduino and temperature inputs and temperature outputs and controls and solid state relays. I picked the gas chromatograph because of its simplicity. You have an injector where you inject your sample. That would be at a heated constant temperature, and that is connected to a carrier gas, and then goes through a packed column, which helps separate the compounds in your sample injection, which then go through the column. And the Arduino would be able to control oven ramp temperatures as well through. What I like so much about the open source firmware such as the Arduino is the community, the open source community involvement. Really has given me access to PID code, libraries for interfacing with the thermocouple chips, and a lot of code just for basic input output. And the community involvement in that makes advancing a project so much more easier, really driving down your cost in research and development. Also, my experience is that when I used a gas chromatograph almost daily for the past almost 20 years, and although in college I used one time, and it broke down the night we used it, and it was a old 25-year-old model. It was so old that computer integration of the area peaks was not even included. We basically printed out our peaks on plotting paper, rolling plotting paper, and then you cut out the peaks with scissors and weighed the separate peaks to get percent composition, and you used a stopwatch to determine retention times of the peaks and the compounds in the sample. Along with the okay, so I've covered the injection, and the column and the oven temperature, which can all be easily controlled by the Arduino. And then you have the detector, and I'm looking at a thermal conductivity detector, a TCD thermal conductivity detector, and it's basically a Wheatstone bridge, which half of it is measuring carrier gas, neutral gas such as helium, and the other half would be measuring carrier gas and sample gas. And as the sample gas passes over half of the Wheatstone bridge, you get a change in resistance of the wire, and you can get a delta, and that can create a peak. I found some good software out there called OpenChrome software that works really well in interfacing with the open source firmware that I use. And the plan is to use OpenChrome software. Getting back to my education, the gas chromatograph was so expensive that we could not afford to use a gas chromatograph that I would use every day as soon as I got a job. And within a year of that ancient 30-year-old gas chromatograph laboratory night, I was working on $20,000 Hewlett-Packard and Perkin-Elmer gas chromatographs. I see the simplicity of the gas chromatograph as something easily reproducible, and hopefully with enough quality work on the detector, we will be able to have very quality results. Through open firmware such as the Arduino and through the open source software, I hope to drive down the costs of a gas chromatograph that could be used in a college, in small business research applications and third world country research applications, developing even a market where research would not even happen because of the cost of laboratory equipment. Right now, our best guess is about $1,200 total to build a gas chromatograph. I've invested probably about $300 so far, and although I have had the luxury of saving up money and budgeting out enough that I'm going to tackle this full-time for the next 6 to 9 months, parts costs are there, and I would like some help in that area. So I've come to experiment.com. I'm not ready to crowdfund the whole entire company or project, or seek large investors, but I would like to take this first step and develop my first gas chromatograph from scratch. I've just received buy-in from two of our largest respected members of TXRX Labs here in Houston. One of our best PCB experts, polychlorinated biphenyl boards, computer boards, circuit boards, so that when the wiring is all figured out, we're using, right now, the plan is 3 separate Arduino cards for injection, oven control, and detector control, and data acquisition. We would custom make our own PCB boards. All this would be open source. I'm already documenting everything on my website, ChromatograDIY.wordpress.com. And I have had a proposition that these two members would help me in my project. So in that huge boost to my confidence, I'm hoping to gain basically some spending money to advance this a little quicker. Usually I take a lot of time shopping for parts and the best prices, and I still plan on doing that, but I'd like to see I'd like to have the ability to advance the project a little quicker. The other guy, besides our PCB manufacturer guy, and a huge electronics and computer programming specialist, is another guy, Mark Sullivan, who is probably our best electrician-minded person here, hugely skilled in everything electronic for the past 40 years, and a maintenance guy for Hewlett-Packard. So this is a big plus, and we meet this Sunday to discuss the actual details of the collaboration. Mark has even offered to tackle the TCD detector himself, and so I'd like to take a couple more minutes to show you some of the equipment we have here at the lab, not just my messy workbench. But this is a very viable project, and I think it has huge implications for putting gas chromatographs in colleges for students to learn, and everything being open source, they will be able to learn the equipment themselves and seek help in the community, in the open source community online, and to be able to even repair the parts themselves and buy them cheaply, which I think will increase research and education in gas chromatographs at the college level, and not just learning the minute you walk in the door at your first job, where you will be working with gas chromatographs every day. So I think that there's a huge disconnect there, and the possibility for third world country research or emerging markets research to greatly expand is there. So, but the first goal is to build a gas chromatograph. So I'm seeking $1,200. These boards cost about $35. The relays cost about $35, and I'm going to need some steel parts, both for the injector port and the detector part, which is basically a stainless steel block with holes drilled in it for the wires for the TCD. And I will need a box oven built, and I will need a better quality fan and heating coil. Even though this works pretty good, I'll take a few seconds to take some video of the lab here. This would be some of our electronics benches, just a small part of them. This is a class that's actually in progress, developing your own PCB board. Here you can see we have 3D printers actually in use. We have 2 3D printers, and this is our newest edition of Form 1 printer. It's an actual laser printer. It works off ultraviolet solution using a laser from the bottom to grow the piece from the bottom up instead of printing the piece from the top down, as this one is doing. We have lots of good equipment. This will be our 3D imaging area where it's still being put together. And we have a nice laser cutter right here. Does a very good job. This is a 3D printer that the shop is actually building on its own, calling themselves Team Delta. Has lots of potential. And back here in the warehouse, this is our metalworking warehouse where I would be manufacturing a lot of the metallic parts, specifically injection ports, TCD, stainless steel blocks. As you can see, we have lots of milling and machining equipment. This baby, we just replaced the circuit board, and we are about to get it up and running. Lots of good equipment here. Manual mills and CAD operated mills. As you can see, this little CAD operated machine gets used a lot. We have a large supply of welding equipment. I'll probably be using a lot of this to build my box, my oven, and this is a plasma cam table. Helps me cut sheets using CAD CAM software by laser. Plasma cutting. Very accurate and very speedy. So as you can see, the warehouse itself is has a lot of potential, and we even have a whole other woodworking shop, which I'm not even going to film at this time. On a side note, I'll just show you where we teach a lot of our classes. A lot of information is shared here. Multiple classes: CNC milling, laser cutting, 3D printing, programming, machining, PCB manufacture, custom boards. I just think it's a nice addition to TXR's labs. This is actually interesting just for the scientists out there. It's actually an electron microscope. And since we are a non-profit organization here, we get a lot of equipment donated. The electron microscope is not up and running, but there are dreams to get it up and running. With that, I think I'm probably going to stop here. I've probably run over time, and I'm going to have fun trying to reduce this video to the size that would fit on the website. But I wanted to get a video out there, and hopefully I've done a good job of halfway explaining the goal. But ultimately the goal is to build a gas chromatograph from scratch, and I could sure use some help financially. I'm just setting a $1,200 goal. I think it's real simple, definitely reachable, and it would go straight to parts basically. So thank you for your time. Have a good day. Bye.